Did you know that one part of an aircraft is designed to work against it? The horizontal tail, located at the rear of the aircraft, produces a downward force opposite to the lift generated by the main wing. This intentionally reduces the aircraft's total lifting force. At first, that sounds inefficient. Yet almost every civil airliner, trainer aircraft, and general aviation aircraft uses this design. Why would engineers deliberately reduce lift? Let's find out. Welcome to Aerosift Pravaha, bringing you fascinating aviation facts. Let's begin with the paradox. The horizontal tail generates a downward aerodynamic force behind the aircraft's center of gravity. Because it acts far behind the center of gravity, it creates a nose-up pitching moment that balances the aircraft. The elevator controls the amount of this force. This stability comes with a penalty. The wing must now generate enough lift to support both the aircraft's weight and the tail's downward force. More lift creates more induced drag, while the tail itself adds structural weight and aerodynamic drag. As a result, a conventional aircraft is slightly less aerodynamically efficient. Even so, almost every civil aircraft uses this arrangement because stability is more valuable than maximum efficiency. To understand why the tail is needed, we first need to understand how a cambered wing behaves. A cambered wing naturally produces a nose-down pitching moment. The aerodynamic center, where aerodynamic forces effectively act, is located at about 25% of the wing chord. For stable flight, the aircraft's center of gravity is positioned ahead of this point. As lift increases, the nose-down pitching moment also increases. Without another force to balance it, the nose continues to drop, creating an unstable cycle where lift and pitching moment keep increasing. Preventing this instability is the primary job of the horizontal tail. Now let's see how the horizontal tail solves this problem. The secret is the moment arm. The tail is positioned far behind the center of gravity, typically 3 to 4 times the wing chord length. Since moment equals force multiplied by distance, even a small force acting over a long distance produces a large balancing moment. In most aircraft, the tail generates a downward force of only about 3 to 8% of the aircraft's weight. Although small, the long moment arm creates enough nose-up moment to balance the wing and maintain pitch equilibrium. The elevator changes the tail's angle of attack, increasing or decreasing downforce to control the aircraft's pitch. Some aircraft use an all-flying stabilator, where the entire horizontal tail rotates to provide greater control authority, especially at high speeds. Now we can resolve the paradox. Without a horizontal tail, the aircraft may be more efficient, but it becomes unstable. With the tail producing a small downward force, the wing must generate additional lift. In other words, the tail makes the wing work harder, and that's exactly what gives the aircraft stable flight. Civil aircraft accept this small efficiency penalty because stability reduces pilot workload, satisfies certification requirements, and allows a wider center of gravity range for different passenger, cargo, and fuel loading conditions. In aviation, efficiency is important, but predictability and safety are even more important. That's why conventional aircraft continue to use a horizontal tail. Thanks for watching. Please subscribe for more aviation facts. Have an aviation question you've always wondered about? Leave it in the comments below.